Welcome to the land of waves and sound, Chapter 16. Well, if we're going to demonstrate waves, and I think everyone has a pretty good feel for what a wave looks like. Anyone been to the ocean? Oh yeah, a lot of waves sometimes. Got to be careful. Waves like this, that's not what we're talking about. We're talking about waves that actually could be a light wave, a sound wave, or whatever. I think we have a pretty good feel for that. Now in the back, I've drawn a wave. This particular wave is called a transverse wave. All right, and it kind of looks like a snake. So Mrs. Hessler is very, very scared of snakes, so do not be alarmed. It's only a diagram of one on the board. So this transverse wave actually has a motion to it that kind of goes back and forth like so. Now we associate transverse waves with a few things. Electromagnetic, like light, is a transverse wave. Ocean waves are transverse waves. Now, I'm not sure if you can actually see it, but I have a slinky here. And if we were to actually set this into motion, back and forth, we'd actually see the wave traveling back and forth. And it does kind of undulate back and forth like this. Now, there's a couple properties of this wave that we need to look at. All right, if I draw a line straight down the middle like so, from this midline area, we have a distance, and we call this distance the amplitude. You probably have studied this in your math classes. So the amplitude is not from the top to the bottom. The amplitude is measured from the midline. The top normally we call the peak, and then the bottom we call the trough. Now it's also true, if I've drawn this correctly, that the amplitude also is the distance from the midline to the trough in the bottom of this wave. All right, so if we look at that, we can actually see amplitude here, and then as it drops down, another amplitude in this spot. Now, a couple other things about the waves that we need to know. It's not just how big they are. Like, so we go down the shore, sure, that's important. So if I'm going to go surfing or whatever, the size of the waves really does matter to us. But another thing to consider is how frequently the waves come in. So what I'm going to do is park myself, maybe some area here, just stand along the beach, or maybe I'm sitting there on Santa Monica Pier, and I'm watching. And I look at the waves, and I start to count how many waves go by. All right, so when I start out, I put a big old watch on my hand, and I'm going to actually keep time at what time these waves are going to take. So let's suppose I count for 10 seconds. So as I go through, ready, set, go. All right, the clock is winding, and I count 8 waves go by in 10 seconds. So let's figure out what the frequency is. Frequency is 8 waves per 10 seconds. So the frequency is going to be equal to 8 divided by 10, 0.8. And the word that we use for waves per second, cycles per second, same idea, would end up being the word hertz. So it's abbreviated HZ. It's the same word as Hertz Rent-A-Car. So if you go to Avis or whatever it is, so Hertz Rent-A-Car spelled the same way, abbreviated HZ. And what does this mean? It means that there's 8 waves for every 10 seconds, or there's 0.8 waves for every second that goes by. All right, now if you look at this, let's suppose we double the number of waves in that 10-second pattern. Wouldn't the frequency go up? So if we have twice as many waves, we're going to end up with them coming in more frequently. So what does frequency mean? It's how frequent the waves show up. So if we double that, this would be 16 waves for every 10 seconds. Then the frequency would end up being 16 divided by 10, 1.6 waves every second.